Patrick. How are you?
Pretty good.
And everybody joins. Where are you, Patrick? Is it morning where you are? Or
Uh,
afternoon?
it's morning, yeah, over here at Eastern Standard Time over here, yeah.
Nice. Yeah, morning for me as well.
I wish I was in Hawaii right now, though.
Hello.
Eddie,
Good morning.
morning. Okay, before we start with chapter T and chapter 4 and Eddie's contribution, I just have some quick announcements. One, the Patrick just shared on Discord his slides from chapter 3. So in case anybody wants to look at them, uh, they're here. They're pretty good. And then this week I found that there's gonna be a free lesson, a free call with these two persons, these two people. They are pretty famous in the AI space. Um, and they are hosting a call about improving AI and getting started with evals. It's pretty on the tone of last week and this week's chapter, so I thought it might be useful. I'm gonna share it here in resources, in case anybody wants to join. It's free. Um, what I understand is that it's gonna be part of a paid course, but this lesson specifically is like free, so you don't need to pay anything to me. And yeah, that's it with all the announcements. So, Eddie, uh, feel free to start. Thanks for joining on this.
Yeah, thank you. Can you please enable screen sharing?
It's not enabled. I should enable the settings or yes, all participants. I think you should be able to do it.
Okay, can you see my screen?
Yep.
Okay, so chapter 4. And I want to apply this, let's say, theory on a use case, which is a virtual network architect. As you all know, I'm doing network architecture for a long time, and I'm also building AI systems, different AI systems, including fine-tuning and RAG and agents. I have to admit that I didn't evaluate any AI system I developed so far in the last years, and that's why I think it's a it's a good opportunity for me to practice what I will preach today. So why do we need to evaluate a system in the first place? Is that one good reason is that we want to be sure that our application makes good decisions, maintains factual integrity. We don't want the cost to skyrocket. Another reason, which I think is a good reason, is that if we make a change within our architecture or design change within our solution, how do we know what is the effect of the change? And my honest answer to this question is that I don't, and I'm not able to measure objectively. I just make some for my applications, including advanced RAG or fine tuning. The only assessment which I do is empirical, based on my experience. But I have no, objective metrics. So we have three steps or three big steps to cover. First is to design.
Sorry,
Yeah.
sorry to interrupt.
Yeah.
I think you're presenting slides, but in the sharing screen, we just see a Zoom screen from your browser.
Yeah,
Okay, let me
I
go
had
back.
the same comment.
Let's see if it's working. Now, better?
Yes.
What do you see? Okay.
Yeah, the slide. Nice.
So what I said remains valid. So again, it's an opportunity for everybody, myself included, to apply this evaluation on our practical systems we develop. So I want to move it in this presentation to be more than a simple theory, and I'll try to apply this knowledge to a use case, which is my virtual network architect solution which I developed. Okay, so I said here, why do we need to evaluate? And as I said, one good answer is because we want to test the results of our changes. So how do we know if a change has a positive or negative impact on our overall solution? So we need to measure. The main steps which are part of this evaluation of an AI system is to define the criteria. Which are the criteria which we want to measure a solution against? I would say here that these criteria should have some weights. I mean, we should classify the importance of criteria based on some business metrics. The second big point is to select the model. It's the classical IT question, which we should buy or build. It's an old question. It's not the first time when we have this question. And then the third big point is how we evaluate the AI solution. So we have in AI systems multiple categories. Again, I try to map it to a practical application, which is a virtual network architect. It can be expanded to absolutely any AI solution. So any AI solution should cover a certain domain. Yeah, should be a marketing expert, should be a recommendation engine, should be a writer, anything. Then once we clarify and we decide on a specific domain because we want to have an expert in something, second point is to define this criteria of what is the generation capability. So if the output is hallucination, is nonsense, or if real useful, and to be real useful, it should be factually correct. Then the third criteria which we want is because we talk about fine tuning. Yeah, so we want to make sure that the model has the ability to learn from our instructions. So it's like any process learning. When we teach somebody, let's say, or we make a training for whatever technology or whatever topic, we want to make sure that our data, our, let's say, instructions, our content is correctly perceived and understood by the people which want to learn. So it's a capability which can be more developed or less developed for different models. And last but not least, as I said, last but not least is cost, and of course performance, which is latency. And I say is the last one because usually developers, myself included, I don't care about the cost in the first stages. But then when we go in production, then say, wow, it costs me a lot of money to pay all these API calls, so it's not scalable, so it's not financially feasible. So as I mentioned, these four categories, these four criteria should be classified based on the business requirements. So if we have a business requirement which we don't care about the money, which might be a case for some use cases, then cost and latency, cost is the last problem we should take care of. Again, the order and the weight of each criteria is comes or should be dictated by the business. So it's I know it's a famous book. I think it was written by Daniel Kahneman. I love his book. Conway. It was 7 principles for highly effective people. One of the principles was Conway. Yeah, one of the principles was to start with the end in mind. It's a very, very powerful principle. I love it. It's a universal principle. It can be applied to everything, including for developing IT and AI systems. And I have to admit that I didn't follow it. So I didn't follow it. But now, after this reading these books, yeah, this is the end result that I will be able to apply what I learned. So the idea is that we should start when we want to start building something, literally something, everything, we should start with how do we measure that product. So we should have some clear evaluation criteria even before to start to develop, because that will keep us on track. And I can tell from my experience that without such evaluation criteria from the beginning, the development process goes in hundreds ways. Because there is no framework of reference to, let's say, to narrow down our thinking and our development in certain directions. So I think it's a very, very useful practice to start with evaluation criteria, as the author of this book says. Of course, we also have the business-related aspects of the AI system, which is return of investment. So obviously, everybody or every investor or every CEO or whatever, they want profit, obviously. So how do we measure this profit? It's not trivial for a given AI application. Some AI applications, some systems, some applications, or I should say, for some use cases, is relatively easy to map the revenue, the business revenue, with the AI criteria or AI design. Like fraud detection system, it's simple. I mean, it can be quantified in money. So we can say that an AI solution, a good AI solution, which takes care of fraud detection systems or fraud detection, can save a business $1 million per year. So the value of the AI solution is easily measured in money. But unfortunately, I can tell again from my experience, not all the AI use cases are can be easily mapped to money, to say this is the amount of money you save if you use it. And that might be a challenge when somebody would like to promote within his organization a certain idea. The lack of mapping between an AI idea and the return on investment is a showstopper in many cases. Again, I'm speaking from experience. Please interrupt me anytime you want to, if you want to contribute. Now, first criteria is first criteria should be related to a domain. So whenever an AI solution is designed, it should be specific to a certain domain, like medicine, like marketing, IT, coding, whatever. So it should be a clear domain, and we want to make sure that AI system is an expert within that domain. And the way in which we can assess it is with so-called close-ended tasks, which are relatively easy to evaluate because we have multiple choice questions and we can easily see how good or how bad the model behaves. For other things which are more, let's say, subjective, like summarization, I think summarization is a subjective activity. The measurement is not so easy because, a text, any given text can be packed with a lot of data in relatively small number of words. So the way in which a model can make this summarization, it's not easy to quantify. Another part or another sub capability, let's say, from this generation is that the model should be fluent and coherent. And we noticed, I mean, if you remember from the early days of ChatGPT, fluency coherence was not something which was not a de facto standard, and some output were very messy. And but over time, we noticed that all these things become the new standard, and the industry upgraded also the requirements, which is now safety, for example. Yeah, safety was not at the beginning, was not the most important requirement. But now people are very concerned about toxicity, about political biases, especially about stereotypes. And now the models should be more sophisticated and should be able to meet, let's say, more nuanced requirements like with safety. There are several methods which can verify different sub-criteria like factual consistency, and probably the most important is from my experience was the personal and heuristic-based measurement. So I used my own knowledge to assess the output of the model. Of course, this method is not scalable, and it can be applied on a very narrow domains when somebody has deep expertise. But for all the other domains, this method simply does not work. So that's why we have AI as a judge, which can be used to measure, especially the factual consistency. We have a so-called textual entitlement. It's an interesting concept which describes the relationship between a contradiction neutral or entitlement between a premise and hypothesis. As you know from logic, if the premise is wrong, the hypothesis cannot be correct. So there are some logical links between these concepts which can be leveraged in order to assess the degree of factual consistency of the output. Also, there are, for safety, different set of methods which can be used to detect, as I said, harmful content, harmful instructions, biases, hate speech. I know it's a very complicated field, because I think here we need to go very deeply with the definition of words. What exactly means hate? What exactly means? I mean, so it's not an easy topic here to verify or to provide the safety to the models with regards to their output. Another capability which I mentioned, or criteria, should be that model should have the capability to follow instructions. Yeah, if we make, let's say, a metaphor with, I don't know, training dogs, for example. Yeah, we know that not all dogs have the capability to follow orders. There are some, for example, German Shepherd is well known that he can easily learn orders and commands and instructions, let's say. But not all dogs can have this ability. So, and in the AI world, the same applies here. And I tested it, different open source large language models in the last years to see which one behaves better for instruction following. And my conclusion was that Llama 3 was the best model which is able to follow instructions in my area, which is networking. Yeah, so in networking domain. So there are different benchmarks here which can assess the degree of how good a model is in this area of instruction following, which I think it's probably the most important area, because basically this capability gives to the model the ability to learn. Without this capability, that model is, I mean, open source model is useless. This is my opinion. Role playing is another big topic because it defines the persona for the large language model. So sophisticated models like OpenAI, they have embedded within them, let's say, multiple personas. And in order to maximize the output or to maximize the utility of the output, and in order to receive, let's say, a useful output from such, let's say, model like OpenAI, we need to define the context, or we need to define this persona. Who is OpenAI when he interacts with us? And we can see very easily that the differences in quality between the situation when we play this, or we leverage this role playing, and when we don't, it's huge. So role playing has a big role in this capability, which is instruction following. Last but not least is cost and latency. There are here sub-metrics for the latency. What is the time for the first token? What is the query latency? What is the cost per token? As I said, things become more, let's say, interesting when the solution goes into production and scales. And then this criteria becomes crucial, because the model should, or the overall solution should produce money. So if the cost of API calls is bigger than the cost of subscriptions, for example, then it's not a big business. It's not a big deal. So within this criteria, we have a sub criteria, which is if we go to self-host a model, which comes with a different set of requirements, or to use an API for a provider. Here I can say again from my experience that trying to self-host a model is requires a very deep knowledge in cloud and in designing the infrastructure. So it's not it's not a walk in the park. Is doable, but it's a relatively complex engineering task, I would say. Of course, the cost is the initial cost is a little bit higher at the beginning, but once you have deployed your model within your premise, let's say, or within your private cloud, then you have full control over everything. Weights, the training data. You can fine tune in any way possible, which in case of a provider, this is not necessarily possible. Okay, so I wanted to take an example here, like all these criteria aggregated and applied to a virtual network architect. So for the domain specific, for the first domain specific capability, the first question is for the model is if the knowledge it knows can be correctly and accurately applicable. And in order to do that, or one should be able to apply or to use some benchmarks to test the how knowledgeable is the model in different protocols he was trained with. So my protocol, my large language, my Llama model, which I put it on Hugging Face, which is trained with design stuff, OSPF, BGP. These are some protocols used in networking. Is very good. It's very good because I spend a lot of time with the data set to prepare the data set with all the possible design options, configuration options, etc. And Llama was smart enough. Llama 3.1 was, let's say, good enough to learn this knowledge. And when I asked what is the design recommendation for this scenario, or what is the configuration for this situation, I always received good answers. So another thing we want to avoid is is hallucination. Obviously, personally, I solve this problem using advanced RAG, and but also it's doable to be solved within within a large language model as itself. Yeah. Again, I don't have experience in this area to how to minimize the hallucination within a large language model because I solve it using RAG. But it is possible to using let's say super high quality data to minimize or to eliminate this problem. Or in case of instruction following, which is super critical for this virtual network architect. I want what I expect from a model is that I want to be consistent. Yeah, I want to be able, given a set of requirements and constraints, I want to receive the same answer all the time, no matter in which way I formulate the problem. So yeah, and also cost and latency, which how I said from my personal experience, I didn't care at all even though it costs me a lot of money. But as you want to move something into production, then this cost becomes a real problem if you need to pay it. Okay, next slide. Any questions so far? Okay, now yeah, here we go. Any questions because we just ended the first part, which is this criteria stuff. Any questions to criteria?
No, all clear, I think.
Okay, so the next big question in IT and AI is what is, should you buy it or should you build it? This question is a classical question, especially when it comes, for example, for cloud. It was a big question. Should we build our own private cloud or should we go to hyperscalers? The same here. Should we build our large language model or should we go to all these vendors now, a lot of vendors? So again, in order to answer this question, we need some criteria to measure the possible answers. And in many cases, performance is probably the most important criteria, because you want precision, you want consistency, you want factor to be grounded in truth. And a second category is related about if we need to play between hard and soft attributes. Hard and soft attributes. Hard attributes means things like licenses, like data privacy, like hosting requirements for private large language model. So things which might have implications on the long run. For example, depending or building a solution, let's say only using the OpenAI shop. Now they, as you know, they have this SDK for agents. Is nice. It's easy, probably. More or less expensive, but it's a single provider. That solution depends 100% by one single vendor. It's called vendor locked-in IT, when all the components of a solution come from one single vendor. So it's can it be a business risk if my business depends on one single provider? Of course. Yeah. So all these things should be carefully balanced and measured. Soft attributes is related to all these, let's say, all these things like factual consistency, performance, how accurate, how safe is the output. So yeah, so this might be, let's say, the most important attributes, or what should I say, better criteria, which should be considered when we need to take this decision, buy or build. It's a big decision. I can say it's a big decision, has a lot of, might have a lot of business impact on the long term. And again, for me, the reference when we need to assess the answers to these questions is what are the business requirements. At the end of the day, everything depends on the business requirements. The business requirements should represent the single reference framework when this kind of decisions are made. So the author of the book defined the workflow from several steps. So he suggests here to filter the models based on the hard attributes, which I said licenses, which were privacy. Then we should narrow down these candidates using different public benchmarks. Then, in my opinion, the most important thing is to do our own testing, which should be specific to our use case, specific to what our application should solve. And of course, monitoring, which is a mandatory part of any IT system, including AI systems. things should be monitored and improved. Why not? So yeah, so buy or build decision. It's a tough call. It's a tough call, especially if the business has no clarity, because I think this is, again, based on my own experience, talking with other people which did similar things. Lack of clarity at the business level makes this question to be very, very tough, and to move the risks basically from the business owner shoulders to the engineers. A classical classical problem. Okay, so we have the open source models versus commercial APIs. For me, or not for me, for a given use case, I think should be assessed what is the real need for control. I think this is the most important question. What is for my given application or for my given use case, do I really need full control over the AI solution or not? Because if the answer is no, then an API model can be a valid and better solution. But if the answer is yes, I want full control over training data, over weights, over fine-tuning processes, then obviously the commercial models is not option anymore. So we need to go with testing and playing with all these open source models which are available. Here, I've copied print screen from the book with all the dimensions which should be assessed when such decision should be made. There are 7 dimensions, 1, 2, 3, 7 dimensions. And again, on top of these dimensions should be the business requirements. Another interesting point is navigated through these benchmarks and leaderboards. Personally, for me, this stuff is only informative. I didn't pay much attention on these benchmarks because the things they are measuring against might be not relevant for my use cases, and I prefer to assess my own models myself. Yeah, again, not a scalable option, definitely, and cannot be applicable for other use cases than the use case I worked on, which was the virtual network architect. But benchmarking and benchmarking definitely, and public leaderboards, and from Hugging Face, from Stanford, there are a lot of sources can be help to make a decision. Yeah, there are of course pros and cons for these benchmarks. One can create its own leaderboards and benchmark, which to be relevant to the use case. I think this is the best approach to build your own benchmark for your specific use case, which you know exactly what you should be providing, and to measure any future development or any future changes in design, in whatever, against this benchmark, which is very, very specific to the problems I want to solve. I can make a metaphor. It's like I am an IT guy. Yes, I'm a network architect, and I have every year performance assessment from my manager, and we have a list with metrics I need to fill. Yeah, I need to meet, and which are related with the complexity of the projects, which are related to optimization, etc. I mean, there are specific metrics for a human when he is assessed, when his performance is assessed, let's say every year. And the metrics which my boss applies to me are different than the metrics the same boss applies to a network engineer or maybe another architect which is a junior. Or so what I want to say is that in real life, this benchmark is very, very customized to a particular, let's say, to a particular situation, a particular person, as I said. So the same logic should apply to, or the same logic I apply, not should, I apply to this benchmarking, is that I built a virtual architect, which is a replica of myself, and I apply the same criteria as my boss applies to myself. So I apply the same criteria as a benchmark to this model. So very, very specific and very, very customized. And then every change I make in the future, like changing the model or maybe going to OpenAI or maybe changing the RAG architecture or adding new agents or whatever, then will be measured against that particular benchmark. Another problems which should be taken into account is this data contamination. Yeah, here is a very gray area for commercial models. Well, the reason is obvious. People or this company, they are not very happy sharing their training data for hundreds of reasons. So basically, it's a black box. So we cannot say anything. I mean, the author, yeah.
Eddie, just one question. At least for me, the screen sharing is stuck on slide 15. I don't know if you already move on.
Yes, I did. Yeah, let me.
On the topic, I know, and I follow everything that you just said, but I think this slide is stuck there.
Slide 15, you said? Okay,
yes.
so
okay, now we're there.
Cool. Yeah. I see my screen frozen. My fault. Okay, so I said about this discussion Eddie, about yes.
Sorry to interrupt, but can you just go from slide 15 and then kind of just quickly just to a very 10 second step by step to the current slide? Thank you so much.
Yeah. See, sure. Okay, so the big question in IT is if we build something or rewire it, and the options, best options are modulated, let's say, by some requirements, and the requirements or the dimensions we need to analyze when we take when we want to answer to this question, buy or build, should be assessed by the business criteria. So, for example, if data privacy is the most important business requirement, because let's say you have a hospital, and you are working with private data with then this stuff will rule out any commercial AI solution. So it will be obvious that the solution is to deploy your own large language model, and you have full control over data, over training data, fine-tuning data. You put your machines within a very, very secure environment within your premises. So yeah, so if you have, let's say, a marketing agency and you are working with generic data, my performance might be the #1 business criteria for you. And then say, okay, if the performance is the most important criteria for me, and by performance I mean from how many to keep people on my web page as much as possible, to try to create a funnel with potential buyers for my products. So there are some, and these numbers, let's say, these KPIs, metric KPI, these marketing KPIs can be easily measured in how much sales you are making, how big is your funnel, and these numbers depend by the quality and the performance of your solution. And in this case, the problem with data privacy is secondary. It's not #1. Yeah, so you can say, okay, I'm going to I'm going to OpenAI or other public vendor. So again, these dimensions should be weighted. Yeah, should be weighted. Not all of them are equal. From the business point of view, should be weighted. And let's say this is how this is how I take any decision. So I have some criteria, and I weight each criteria with a number, and then I compute for option 1 what is the score, and for option 2 what is the score, and I compare which score is bigger. Now, and then if the score is bigger, that it means that the cumulated weighted value for each criteria is better, and I need to take option B. Yeah. And here talking about benchmarks, and here benchmark, I said that, the author said, is that there are a lot of public benchmarks. Not all of them are reliable, so that makes them not so trustworthy, let's put it this way. And here I mentioned that I'm on slide 18 now. Please tell me if you don't see it 18. So
we see 20. At least I see 20.
You see 20?
20.
Yeah, I think you're on 20, which is model selection from AI applications. Number 4, data contamination issues.
Oh, okay. It's strange. So I was on 18 because you said to go back. So now I'm on 18. Do you see 18?
No.
It's still on 20.
Actually, we don't see the presentation. We see the software itself.
Okay.
The editor.
Sorry. Yeah. Let me stop a little bit.
In the beginning, we saw like the stuff.
Can you see page 18?
Yes.
Page 18?
Yes.
Yeah, page 18. So in page, so in these 2-3 slides is about how we should use these public benchmarks and leaderboards. And there is a lot of companies which are providing these benchmarks. And I said here that in my case, I prefer to build, or I prefer the option to build my own benchmark, because my own benchmark will be very custom to the things which are relevant and important for my AI solution. So then for every change I will make in my design, like changing the large language model, or I don't know, adding new agents or whatever, then my reference, which will be my benchmark, will measure one design against the other. But the benchmark will represent the very, very specific criteria for my solution. And here I made a metaphor with my boss assessing my skills, and that I said that the criteria my boss is using to assess are different than the criteria he's using to assess one of my other colleagues. So the same principle should be applied here. I mean, I would say that the same principle is more, let's say, is applicable here, and can be very precise in assessment if we create a benchmark which relates one-to-one to exactly what my AI solution should provide. Yeah. Okay. 18, 19. So now data contamination, slide number 20. 20. Yes, number 20. Yeah. So data contamination, it's training a model with data which is problematic to be, and it's like training a model with test data or validation data. So, and then we use a benchmark or use this validation data to see how good the model performs. It's like cheating. It's like cheating at an exam. Yeah, you learn the solutions for the problems which are you ask the exam. So the evaluation is completely useless. Yeah. So, but we don't know if the stuff which is used for benchmarking was used or not for training. We don't know that because well, we don't have access to this data. So how relevant is the benchmarking if we don't know if the training data contains the answer to the questions used by that benchmark? We don't know. So this is an argument, or this is a reason why somebody would say, okay, I want full control over my data, over my training data, because I want to honestly assess my model against, let's say, my benchmark or another benchmark, but I will be sure that the questions he used to measure the quality are not part of the training. Yeah, are not part of the training. So in this way, we can make sure that our model is able to answer to things he never seen. Okay. Okay, so now the last section of this chapter was to design a pipeline, how to evaluate a model for open-ended tasks. I hope is that the difference between open-ended and closed-ended task is clear, right? Or okay, so for example, the idea here is that we need to split the system into subsystems and to assess every subsystem and then to assess the entire system. It's an example here with a system which extracts employment details from a PDF and extract text and then identify the name of the employer in the text. So for example, this can be an application for an HR, a recruitment company. So that requires an evaluation to see how accurate is the how fast and how accurate is the outcome. In this case, the name of the employer, and the author suggests here two levels of evaluation: one so-called turn-based evaluation and task-based evaluation. So turn-based, how I understand that is task-based is it's a metric for the entire job, yeah, and turn-based is a metric which is measures the number of iteration between the model and the user. This is how I understand the stuff here. Okay, so the steps to build this pipeline are the following. So first we need to split it. Yeah, we need to see which are the components of the system. Yeah, it can be, for example, RAG. We can have agents. We can have several large language models. Every piece from this architecture is independent. It's a component which should be measured separately. Because if we see that, let's say, a large language model was poorly trained, that will be a source of bad answers. But we spotted the root cause, and the root cause might be a large language model which was not okay for, or is not properly trained. Another cool stuff here, which it was revealed to me by this guy, the author of this book, is this connection between these metrics and the business. At the end of the day, this is the most important thing, in my opinion, to be able to map to the business a metric. Like, for example, to say the performance or the quality of the model was measured, I don't know, with a certain number, and this certain number, let's say 8 out of 10, is mapped to 100 customer with 5 new customers. Yeah, it's a very powerful idea to be able to correlate the business metrics like new customers, how much money were saved, or how many hours, for that matter, were saved, and with a certain metric of the system. Yeah, I think this is the take from this page is this connection between these metrics and the business. What is the business impact? at the end of the day, this is the reason why this stuff is built in the first place, to positively impact the business. And if we're able to measure that, it's perfect. Another third step is to define criteria for different things. For example, to identify toxicity, to measure the semantic similarity, to use AI judge for consistency, even human evaluation. Again, it's a good evaluation method, and and then also, of course, to combine these methods and to balance against to balance between the quality and the cost. So we have, I see it as a triangle where you have the quality, we have the quality, we have the cost, and we have the precision of the model. So, and we can stretch this triangle in different ways based on the what is more important. As I said, if cost is more important, then if we make it smaller, this part of the triangle, then it will impact the others. Another step, I think it was is to curate the evaluation data, and I will give an example after that to see what does it mean to curate and make data annotation, especially for and this data annotation curation should be connected or has to do with the real production data. So at the end of the day, the single source of truth is the production environment, whatever it is. It can be IT environment, it can be a factory, it can be anything. This environment, the real environment on which an AI solution operates on top of that, this is basically the single source of truth. And then we need to measure this evaluation and to evaluate it and to see if things can be reproducible, if things are stable, if things are consistent, especially for consistent, because we want the same answer every time we answer the same question. And of course, monitoring, which is part of the any evaluation pipeline. And here an example, my favorite part here, how to build an evaluation for a virtual network architect. We can replace the network architect with anything, with a doctor, with, I don't know, with a teacher, with anything, marketing expert, anything. Okay, so I need to define a context. I mean, I need to define a problem I want to solve in the first place, and I want to build a virtual network architect to help network engineers to do things like configuration, troubleshoot, etc. And I need to define also the technologies. Here are some acronyms, but not important. These are some technologies. So now if we go back through the steps, but now this time apply to this problem. So we need to take, as I said, or not as I said, as the author said, we need to evaluate independently all the subsystems. So first we take the query. We see how the query is parsed, because it's important how this query is parsed, because this is how the large language model will answer to. And we need to see how accurately the parsing of my query is interpreted and is structured into networking language, because it's a networking architect at the end of the day. Then I want to see how stuff is generated. I want this stuff to be formatted and generated in certain specific ways, like JSON or like CLI, means command line interface. And then I want to assess how accurate is this stuff. I mean, this is super critical, because if one letter is wrong here, that will mess up everything. Then in my example with the virtual architect, I also have a RAG system, part of the architecture. I want to assess how relevant are the relative documents from my RAG, which I build the RAG, so I know the content of this database. So, and then I measure because I know the content of the RAG, of the database, I'm able to measure what is the relevance degree of the outcome, because I know the content, I know which question I ask, and I would expect to receive certain chunks. And if I receive different chunks, then I will measure how good is this retrieval from 0 to 1 or from 1 to 10, or it doesn't matter. So, for example, I want this model to help me as an architect to design a solution, a network, with 2 data centers and 5 branches. So, so if a customer asks me this question, please help me to design SD-WAN network with 2 data centers, 5 branches, I run through several thinking processes in my head, and I need to understand very, very clear the requirements. What does it mean by data center, if it's cloud or private? What does it mean by SD-WAN? So I want to validate that we have the same meaning for the words. So that I want to make sure that I understood correctly the requirement. So I need somehow now to, let's say, my thinking process to be translated into the model. So I want to make sure that the model understood the requirements. The model is able to go to this vendor called Cisco and to read whatever documentation is available, and to see also on Cisco is a vendor in networking, to see also on Cisco which are the best practices, because this is what an architect would do, to see what are the best practices for this particular requirement. So, and because I want the answer to come from this area, from where the best practice resides, like I would do as a human. So all these things should be evaluated, and then based on the outcome from the AI system, I would say, okay, here it's not precise, here the accuracy was not as I would do it, etc. So then, let's say, I receive, let's say, some configuration. I ask, how can I configure BGP as a protocol for this situation? And I receive an answer. And I want to see if the answer is correct, because if I mess up this stuff, then everything will go down. So I want to make sure that whatever configuration is generated by the large language model is super accurate. Then I want also maybe to see if the configuration which is generated is compliant with the security standards, because the customer might be, I don't know, a bank, and they might have very, very tough security standards, especially in Europe. And I want to make sure that this stuff is compliant with the security regulation which are in place for IT. Cost and latency is also a factor. It's not important in this context. But what is important is that I expect I need to assess this virtual architect to behave like an experimented real architect. And here how I define different, how I can define different guidelines, different criteria. Like I said, scores between 0 and 1, between 1 and 10, doesn't matter. And then to see how accurate is the answer across all my dimensions I defined. And here is the cool stuff which I mentioned earlier, is that I want to map the metrics to business outcomes. So if I say, okay, if accuracy of my model is bigger than 90%, then the engineers will need to the workload of the engineer is 70%, and everybody can compute what does it mean in dollars. An engineer makes, I don't know how much money per year, and the workload is reduced to 70%. So you saved 70% of the money. It's easy, and it's easy to quantify the dollar value of the AI solution using this metric, which I think is very cool. Using this metric. So if I want to save 80%, then I need to somehow increase, I don't know how, somehow to increase the accuracy. So I need to make testing, and then I go to management and say, look, man, I saved you 80% of the workload. Or security compliance. Well, here you want to be 100%, because if you have a breach, or if you have a problem with security, then can go wrong in many ways, and more difficult to quantify it in money. but still it's something which is relevant for I think any or most of the AI solutions, security. And here the different evaluation methods for each dimension, which is important to me. Yeah. So these are the things which are important to me for a virtual architect. Yeah, to be very, very accurate in this domain, which is network architecture, to factual consistency 100%. I don't want to mess up or to hallucinate or innovate. I don't want to make things up. I want to be very, very good in learning from instructions. Security, no comment, and latency. It's related to it's security and performance is related to, or latency is related to user experience. How good is their interaction between the users and with the AI application. Okay, and then of course to annotate and create this evaluation data, because as I said, at the end of the day, the source of truth is the network where these things should be applied. So I would go to the real environment and to annotate data with ground truth solutions, because this is, as I said, this is the single source of truth at the end of the day. How the reality looks like is how the environment is configured. And measure the how reliable is the pipeline. So here is, you can make stress testing, you can repeat the same things over and over to see if the answer is the same. Yeah, and of course AI judges is also a good idea here. And monitoring and iteration, yeah, so it's something which is standard in IT/AI. This stuff should continually be monitored, should continually be improved. New models are coming, etc. So it's something which monitoring is part of any AI system. And with that, I ended at the end of the presentation.
Awesome. Any question?
No questions. Really good walkthrough. Straightforward. Thank you, sir.
Yeah, thank you.
Yeah, really good summary. Thanks a lot, Eddie. As usual, very nice, high quality presentation.
I think it's only thing I have is it's just a criticism of the book. It's a great book. I mean, I'm not saying it's a bad book, but you only learn by criticizing to a certain extent.
Correct.
So I like the jargon of pipeline, but it's very vague on the details. We are not getting anything like, okay, use GitHub and tie these three things together. No, nothing like that. It's just sort of like pipeline, and then it's all general. And there's nothing getting us closer to at least how we could structure a pipeline with, different tools or ideas. So it's a great idea. I'm thinking the more of it's going to come on later in the book, or maybe it's just more general. I'd like to see more of the specifics, but I'm not saying it's horrible. I'm just, that's how I'm learning is I'm always fighting with the system. So hopefully as I fight, I will learn more.
Yeah.
If I may add to that, Patrick, you're absolutely right. It's important for us to be skeptical, critical of the content, because it helps us learn individually. But I will say that, so I spent this past week creating the evaluation criteria for multiple LLMs going into these agentic AI systems that we've developed, we've deployed, and we need the domain experts who are all non-technical. These are people who, at best, you're lucky if they've used ChatGPT, just the free one. Right? But you need them because they bring a tremendous amount of domain expertise, and you need them to assess and test every potential variation of some content that will across different countries, different parts of the company, and so on. So you've got I've got 60 plus people, and they all need to look at it. So, and the way to explain it was exactly as Chip put it. Try, because you don't want to spell out, hey, test this prompt and followed by this prompt and this prompt, because then you're just going to get the repeat 60 times repetition of everything I've just done myself. That's not helpful. You need people to be able to scale up the evaluations. And I think this, while this content may seem fairly vague, it isn't. When you put it into practice and you need a guide, it resonated.
Yeah, I think the pipeline is a good point. I think this pipeline should be something very, use case specific. Should be use case specific, because every use case has its own, let's say, components with its own evaluation metrics and requirements and constraints, which are specific to these subcomponents. And the pipeline should be a one-to-one replica of that architecture with all its characteristics.
Mm-hmm.
And
I also think,
Mesh said, it's a trial and error. At the end of the day, I think it's a trial and error approach. We're just testing, playing with different stuff. I don't know. Somebody can say, "Look, man, this is the solution. 1, 2, 3, 4." No, I don't think so. I think it's a testing and trial and error stuff.
Yeah, specifically in evaluation, everything that most of the content that I read on evaluation tends to be very vague. And I guess it's also because it's one of the hardest things to do right now. Like before, it was easier because the models were a bit dumber. It was as Eddie said at some point. For example, what was the point that you said with coherence? Like models were not coherent, so we turn out to simple metrics to measure like that the outputs were accurate, and that was easy. But nowadays, everything seems coherent, everything seems accurate. But sometimes it's in the details that the sentence that the model output is not actually accurate, and it needs even like knowledge from a expert human to notice that. So in evaluation, then everything seems to be very vague because we don't have like the full solution yet, or I don't know if we will have it, but that's why it also tends to be vague. So it's open because it's an open problem.
But let's try to see how we solve this problem in real life. So you have let's say, Patrick, you are a manager. Yeah, you are a manager for a team, and you need to make assessments of your people. Yeah, and let's say some of them have the same jobs, identical job descriptions. Others have different job descriptions, different levels of seniority, etc. Okay, so if you have different levels of seniority, different job description, it's easy. Yeah, you have clear metrics for everybody. But if you have the same type of people with the same level of seniority, the difference between these two guys will be their personality, their profile, psychological profile. Yeah, and you, based on your specific business requirements for your business, you will be able to assess these psychological characteristics of these two guys, which have the same role, the same seniority level, everything, but they are different, obviously. Yeah, their DNA is different, and they have different psychological profiles, against a business metric, which is, let's say, to be likable, because they need to interact with the customer. Yeah, and one of them is very extroverted and he laughs all the day and is a very likable person. The other one is not. So then you apply this, let's say, this thinking to say, okay, this guy which is more extroverted is better for this business setup to go in front of the customer because he's a very funny guy. Both are experts, yeah, but this guy is better for the business, yeah, and the second guy should stay in the backend, yeah. So what I want to say here in this example, in real case example, you design an evaluation system taking into account all the characteristics of the persons, yeah. So you don't apply a template. It's impossible. I mean, you can, but you cannot apply a template. You need to customize your, let's say, your evaluation system to every individual. That makes evaluation difficult and custom and specific. I hope it makes sense. If this is my opinion, I mean, maybe it's wrong, but
I have to get more into the actual production of a system. I haven't gotten that far. I'm more going theoretically based on when I hear pipeline and talking more systematically, but largely we're ad hoc, just editing prompts. I don't see the systematic quality yet there, but I think partly it's my knowledge base. Maybe if I start doing it more in the future, then I'll have better ideas on how I can make it more systematic, automatic, and develop a pipeline, a set of tools that can do it for me. So part of it is my knowledge base, but I think as I evolve, I will find ways to get there.
But you, Patrick, you said last time that you have some networking background, right?
But definitely, I have a strong IT background, networking background, programming background.
Okay, perfect. Okay, so networking. So let's think of a pipeline like, let's say we build 3 agents. Yeah. Okay, no, let's go one step back. So in reality, we have a guy which is monitoring the network. Yeah. And then he sees a problem. Yeah, something goes down, and then he reports this problem to, I don't know, to a level 2. Yeah, which is a more senior guy. And level 2 says, yeah, okay, so we need to make a change in BGP. And then he goes to a guy which implements this stuff. And so basically, these 3 people should be mapped to, or could be, I did it, by the way. I publish on my website. So these 3 guys can be mapped to 3 agents. Yeah. So we have a pipeline, like we have in reality a pipeline. In reality, we have a process, a communication process. It's a pipeline between the layer 1 engineer, which talks to layer 2 engineer, which hand over to layer 3 engineer, which solves the problem. The layer 2 engineer solves the problem. Was the most senior. Okay. So it's a pipeline. It's a process. Now let's apply it to IT, to agents. So we design a layer 1 agent, a layer 2 agent, and a layer 3. The input in the layer 1 agent is the networking data, like interface down. Then this guy notices the problem and he outputs a problem to level 2. And level 2 says, well, I'm not senior enough. He outputs the problem to level 3. And level 3 goes to the network and solves the problem. So we have a pipeline.
Right. But I'm thinking of pipeline as, GitHub and that end-to-end, where it's automatic set of.
Definitely, definitely. But the
point
is
I don't think it's that far evolved, which is part of what Chip Huyen had mentioned. Part of the criticism of the evolution of these systems is that the tools aren't that well developed. So maybe in another couple of years, it will be more developed. But I think it's more ad hoc still, a little bit more freewheeling because the infrastructure hasn't caught up with the needs of the community.
Yeah. So, this is my take on this stuff with pipeline, is that it's something which should be specific to a environment, to a use case. It should solve a specific problem. And since the problem has its own particularities, the pipeline should be very custom. And it's a sequence of tools, basically, which has each tool has its own capabilities, and it takes an input and sends the output as an input for the next one. And you have, like, as I said, in real life, in real world, we have a sequence of interactions between people which solve a problem. And this is how I visualize, or this is how I conceptualize this concept of pipeline, by a sequence of tools which solve problem, a bigger problem. Yeah.
I see Naveen. Go ahead.
Yeah. I just wanted to share take of mine. And again, this is in the spirit of discussing and trying to understand. Am I audible? I hope I am audible.
Yeah.
Yes.
Yeah. First of all, thanks, Eddie, for the chapter part. That was really helpful there. So where I'm coming from is that there was a time in life when I was an academic, and then I have been a practitioner, building a business there. And the more I read Chip Huyen's work, and obviously, she's coming from an academic point of view there. And the reason why it really strikes me is that it seems the advice is more for where I can build more close-ended systems on there. For example, if I'm trying to build let's say a self-flying aeroplane, and there's a standard of correctness that I need to hit. So a lot of in the evaluation choices and all, I can keep measuring, has it hit that mark or not? Is it able to fly at this temperature, or the wind speed, all of that. The more close-ended the problem. But if I'm trying to create an AI system to select Hollywood blockbusters, let's say that, to select blockbusters, that can on there, and I'm not able to map these criteria on there onto more open-ended problems. And where I'm coming from is that the entrepreneur is looking out for new opportunities, new product opportunities, new applications. And what comes across to me is that this evaluation part is a lot more front loaded, that you have all this evaluation and you need to keep matching all of that. But when I look at Andre Karpathy or more Sam Altman or Elon Musk's take, the keyword is not evaluation, the keyword is iteration. Right? You iterate, put it out there, get feedback, users, adoption, engagement. The more mistakes, the more you get to know early on, because you don't even know what you're really trying to crack in a way. The more sunlight is there on your, on the efforts all out there, it is much more productive there. And there are folks who do evaluation like that, not to take in. But the keyword that strikes me is iteration rather than evaluation. And again, in coming back to I remember Faisal Lee, I'm sure I'm pronouncing it wrong. She had that whole data set that was there, which really set the benchmark in terms of correctness of image matching, all of that. But it took something like ChatGPT to kind of to break it out in terms of actual usage, iterate and put it out there. There's something about him that I'm missing in terms of having a lot more value for iteration, the value of it. I didn't see that much in this chapter, and I was really curious because in her podcast, and thanks to Mash, who actually posted it, she said that one of the things that she's really concerned about is evaluation there. But when I read it, I found that it has an academic take. I don't see entrepreneurs using evaluation to power AI forward. Businesses, maybe in the more close-ended problems, but a lot of businesses, take evaluation as more like, make sure that, I don't do anything wrong. But to get it really, really right, iteration really pushes there. And again, these are half-formed thoughts which I thought I would share with more experienced practitioners. Yeah.
Yeah, I see a couple of hands raised. I just want to say before that yeah, I feel like entrepreneurs in the early stages of product used to rely more on like vibes of the model, and they're like, okay, this is if the product is not linked to a billion business that could go bankrupt if the model starts saying stupid things, then you just go with vibe evaluation. But yeah, as you said, it is corporate that is putting these to outside people, it might have some, it might cause some disasters. Carlos, I see your hand raised.
First of all, thanks to Eddie for the presentation. It's nice to have words from someone with experience. What I wanted to say is that this reminds me a lot to test development, to test-driven development. It's actually mentioned by Chip at the beginning of the chapter. But it reminds me to the first years when it started being popular, like 15 years ago, something like that. when at the beginning testing was started being in every software project, but it wasn't. We didn't have still that much of a concept of test-driven development where you write the test before you write the software. So it was more like you write something and then you add some tests to ensure some parts of the code that you need to ensure, like some parts that your exposed API or things like that. So it reminds me like we are more or less there. The parts that you're going to write tests are the parts that you are going to expose. You're not going to automate everything, but there are parts, the parts that you write tests are normally the parts that you don't want your test to your code to fail even if you change it. That's basically the idea of the test. If you're not going to change it, we wouldn't need tests. You normally need tests because you are going to be maintaining and you're going to be changing. So that is the part of your code that you don't want to change when you change other parts. So that's where you write the test. And it seems to me like when we talk about AI, we are more or less in that stage. Like we probably will have tests, automated tests for a lot of stuff. But right now, if you're not going to be changing your model because you choose Claude because you're going to be doing a lot of code, then you're going to be using it for a year. You're not going to be changing it every day. So you are going to build other tests upon it, and you're not going to need the other ones. So
Yeah, I agree. Just sort of going backwards from what Carlos said and how Naveen outlined how you do those evaluations, and then bringing it back, like even as Patrick explained, how do you do it? Think about it this way, though, that when you do these, set up the evaluations, and exactly as Carlos said, it has to last the test of time. Like you don't want to, you absolutely don't want those errors to come out. But then when you're doing it, you're building these AI models that are cross-functional, which means you're going to have people from different domains, and their focus is only their domain. So you work with people from IT. For them, the models are connected and integrated. And so for them, their world is the model when a user says, my laptop's broken, my keyboard is broken, fix this, and blah, blah, blah. And the chatbot is trying to orchestrate that. That's a big deal. In their world, that is a really big deal. That same model, when it's within human resources, their focus is when a typical employee says, what's my salary? What portion of my salary can I take out as a loan, which certain countries allow the margin loans, or what is my bereavement leave, or I'm about to have a baby, and how it responds. Again, and there's even nuances. Human resources folks want the model to be much more friendly. IT domain people will want the model, the AI, to be very formal and just very exact. Now start going into other functions. It's the same model. It's the same integrated model, but the experience in other functions, now when you start getting to manufacturing, this model is also supporting and serving knowledge and information and insights. Their worldview is also going to change. So as somebody like us here, we're building that model, we have to take this broader view and recognize when you're doing the evaluations, it's easy for a data scientist to say, yeah, if you make if a Netflix algorithm recommends a poor choice movie, oh, well, tough. People, it's not lives lost, but then if it's a model that's working in biotech, and you get even 1% marginal difference in accuracy for a medical algorithm is a matter of life and death, right? Well, when you work with different functions, even the smallest thing may seem like life and death from somebody in IT. I mean, just getting keyboard things right. So you kind of have to take that broader view as well. This stuff is not easy. It may seem easy. It is not when you put it in real world practice. And we haven't even started talking about like the models going off the rails.
Yeah. Thanks, Mash.
Yeah,
Thanks, Carlos.
Just wanted to share one of the best models. There's a new Wired article out about how Claude connected to Cursor. This guy was trying to build something, a game or something. After like 470 prompts, Claude 3.7, the latest version, implemented on Cursor, basically said, dude, you gotta learn how to code this yourself. The model got very paternalistic, said, if you don't figure out how to code this yourself, and I can see what you're trying to do, then you're not going to understand it. This is just how it's wired today. And you gotta love how even, is that an example of a model going off the rails? No, this is a model that honestly begins to feel like AGI, but it is doing exactly what it's structured and trained to do when implemented in, as a code assistant Cursor. Anyway.
Nice. Anything else? Great discussion. Any other question? Nope. Then just one last thing before we go. Is there anybody that would like to take the lead on next week chapter, which is prompt engineering? Any volunteers? No? Crickets?
It's an easier chapter. I would do it myself, but I am just overloaded.
It's probably the most interesting one. I mean, it's gonna be great.
I can
Yeah.
try, and I mean my schedule is a bit varying, but yeah, I can take a shot at it.
Nice. Thanks, Nabil.
Probably Santiago, I'm just checking with you, Santiago Mash. I'm just checking with you folks to take some help.
Of course.
Let me take a shot at it.
Yeah, happy to try to help. It's just like your schedule's really tight, but yes, I'll try to help you and we'll coordinate.
Sure.
Yep. I think I have your email, right? We
Yeah.
exchanged emails a while ago. Nice. Cool. Thank you. All right. Great call today. Then see you next week. Thanks for joining.
Thank
Eddie,
you.
thank you.
Thanks, guys. Take
No
care.
problem. No
Bye.
problem.
Thank you, Eddie.
Thank you.
Aloha.
Ciao,
Aloha.
ciao.
Ciao.